All right, I got to still working on the upper control arms. Okay, now what I've decided is that I need 154 degree bend in here. Okay, the gussets are actually going to get bent at 157. So I'm thinking kind of anything right in that ballpark there. I may be able to just make one bending die and do them the same. So if that shows up well enough in the image, we'll see. But basically, I got on CAD, and this art is generated from the 3D program. I just took an image of the right side, looked at the right side, and then played around with, if I put a space, I need to keep it fairly tight because, you know, the gussets are going to be, you know, coming right in here somewhere. So I need the bending die to be fairly narrow, you know, underneath here. So what I'm doing is, I thought, well, 1/4-inch dowel, steel dowel, would be stout enough. And I wanted a rounded edge so I don't create a bunch of scarring or anything like that. So then I put them 1 inch apart. Okay, and then this is all in CAD. And so in CAD, I was able to measure with the radius that should be on here. Okay, this inner radius here is a 1/2 inch. Okay, and according to the CAD program, that put this outer radius at like 0.875. So based on that anyway, I get from the top of the dowel to the top of that plate right there, basically, the amount of deflection would be 0.161. For the other angle I need, 157, it works out to 168, 0.168. So what I think I'm going to do is, instead of messing around, if you can see this one, instead of messing around with cutting 2 slots, I could actually just do that, though. I could just cut, if I have 1/4-inch dowel, I gotta go check. I could just cut the 2 slots 168 deep, and that would give me yeah, I think that, anyway, I gotta go double check that math. But oh, no, that's right. Yeah, that'll work. Okay, so if I cut 2 1/4-inch slots and drop dowel in there, that means that I can just put my bend in there. And I may just try that. That ought to be quick and easy. I need to find some 1/4-inch dowel first. So what I'm doing here is, I know that these gussets are 1-to-1, so that's where they're going to weld on. And I needed to see about where they're at. Now they're going to be bent slightly, so they're going to be a little shorter probably. But right there at the very least. So, and what I'm doing is I'm looking here and I'm going, okay, well, going straight across this block is plenty big enough. Okay, it takes me all the way to the edge here for support and all the way to the edge here. So it should be big enough. Because the reality is that's where they end. I'm going to put the bend down here somewhere a little bit closer, so that makes it even a little narrower. So let's go look for some dowel. Hopefully I don't break off the edges there. This is just purely a test. I wanted to see how much slop was in there by just using a 1/4-inch cutter and 1/4-inch dowel. I might have to go with like a 3/16 and actually machine the width of 1/4-inch, because 1/4-inch cutter will cut slightly wider than a 1/4-inch. Anyway, I took the calipers and did a depth measurement. Came up with 0.082 from the top down to the recess there. And that from 1/4-inch is 168, which is the dimension I had for how deep I wanted to put those. So now the thing is, put it in the shop press and push a piece of 3/8 inch steel down into there and see what happens. Well, for the first test, I'm pretty pleased with that. It's really friggin' close. Basically, what I can do is I can do the same dimensions, but not cut quite as deep. Okay, and then what I can do is I can come back in and I can machine this center down after testing, and then I can walk that angle right down in there. Right now it's a little extra deep. Now it could be because, you know, you can see I flattened that out because I just pushed way too hard. I also got dimples in here from the dowels. So I'll have to play with that some more. And I got a major dimple right here from by using the right angle die, the push piece. So what I want to do is I want to make a 1/2 inch round die. So before I start adjusting dimensions and stuff like that, I'll use a half-inch round piece to push down in there, make that a little bit more subtle, and see what the bend comes out like. All right, it's just a hair tighter than the 157, and this is with the I put a piece of basically half-inch titanium in there. You can see I still pushed it a little too hard, but got dimples underneath. Not quite as pronounced though, but angle-wise, yeah, we're really close in the ballpark there. So basically, I think I've proven it enough to want to move forward with making the bending die. I'll think about it just a hair more. I might possibly want to machine an angle into this piece instead of using the dowels because of the dimpling. We'll see. If that's the case, I might use something. Yeah, we'll see. I'm still playing around with the bending. You know, I did several yesterday, played around with a couple of things, putting a piece of sheet metal between the pins and that stuff so I didn't get the dimples there from the rods. I'm still getting a big mark on the top here. But bent those into various angles, stuff like that. Some were close and that stuff, but you know, I needed something bigger. So this, you know, is wide enough to put the bend, you know, right there and have it fully supported. Now the thing is and all this is this is just one channel in here. These two rods, if you look at the ends here, basically these are cut off of here. Okay, that is the strut rod. This happens to be out of a 210 strut. So the foam in here was basically just to keep the rods separated. You know, that way they wouldn't roll under when I was trying to put the plate down on top. So I did put the plate down on top, and I did get it to bend. You know, it's a 20-ton press, and it was doing everything it possibly could. So it left a couple of marks on the bottom side here from the rods, and if I remember right, yeah, if you can see that, there's a little harder to see on this one. You might be able to see it on that one. Anyway, so by turning it over here, what I'm looking at is, I was just looking a bunch of information up online, and in order to do the bend I need, basically the bend points, the V should be 3 inches across. I don't think I'm going to try to make it 3 inches across, but I'm definitely going to widen this track up a bit, because those points aren't even at 1 inch right now. So I'm going to whittle out at least another 1/4 inch per side to spread these bars apart, and then try it again and see if it'll bend a little better. Because if it took that much pressure to bend this, the farther apart the points are, the easier it will be to bend. And you can see that I've got at least twice that much metal to bend. So I may have to take a 1/2 inch out per side. We'll see. Just about done messing with the bending for now, I think. So basically what I did was I modified that other plate, and they're still not far enough apart. I bent this piece, okay, and you can see it's still leaving some big marks there. I don't remember which, I think maybe the second bend. That bend there. That one came out just about right. Kind of hard to tell since the way I bent it in there with this piece on there too, but the other one's a little bit shallow. Anyway, that's 3/8 thick, and that was hitting pretty close to the limit. I put it in another one I had that had everything spaced 2 inches, the peaks, my normal V-bending block, and it started to bend it, but just barely. Now what this is this is roughly 4 inches, okay, and where I came to that was I've got just under 1.5 inches here, and another just over 2 inches here. So, you know, between them I had 3.5, under 4 inches. This is a little under 4 inches here. So I wanted to see if there was a chance that I could bend all of that at one time. It might bend easier since it's two smaller pieces, but then it means that my block that I push down with has to be strong enough all the way out to the edges here. So what I may end up doing, and I'll do it later, I want to get back to testing the arm, make sure this design actually works before I bend it all up. I can probably come in with a small isolated bend and bend it here and then bend it there, and I'm sure that it will easily bend that, because you know I can bend this without too much problem. That's even on the narrow. If I were to go back and bend it with the wider, shouldn't have any problem. Anyway, bending stuff basically aside, so what I'm gonna do now is take this arm. This is the test arm. The tubing is too thin. This was just purely for mock-up and everything like that. So I'm going to go ahead and cut these tubes off and see about welding that one into position, and go check all my dimensions on the frame. Okay, I got the flat plate one mounted up. This is the lowered side. Haven't measured yet to see where the caster and camber and all that stuff is. I can already tell the caster's plenty. Looking at the offset of the ball joints there. I'm all the way down at the bottom of the shock travel. I don't have any bump stops here to reference to, so that's a figure out later kind of thing. So I got tons of clearance in here now that I didn't have before. And if I run it through the range of motion, I'm hitting the shock absorber there. Yeah, see, I got a little so that should be the ball. Oh, let's see, is it the ball joint? No, it's the frame hitting. Okay, so I still have not run out of ball joint range of motion. Okay, and if I go down this way, you can see I don't run out of it there either. And that must be ball joint. Yeah, that's the ball joint binding there. But provided I've got my shock dimensions set up correctly, that should be good to go. So I'll take a couple measurements on caster and camber and see what they come out to.